crucial to the city's survival. Steel for cars, trains, buildings. Yet it also once churned out emissions that fouled the air, poisoned the water, and threatened the city's survival. Today, the Cozipa steel mill has cleaned up its act. Recycling is the future, and the plant has seen the light. Cozipa is spending $250 million on cutting-edge equipment to recapture or recycle pollutants at every stage of production. Already, you can measure their progress. A new wastewater recirculation system reduces ammonia discharges by 68%. New smokestack scrubbers slash air pollutants by 98%. And a new water treatment station cuts oil and grease runoff by 99%.
Basically, for each production piece of equipment, there is a corresponding pollution control piece of equipment. More or less, for each dollar invested in production, we have $1 invested in environmental control: air, water, or soil.
Antonio Malinowski is a plant engineer. In the new, improved São Paulo, the plant fits right in. Cozipa is no stranger to recycling. They make their main product partly from scrap. Steel is the world's most recycled material. Each year, plants recycle 400 million tons of steel, enough to construct almost 1,000 Golden Gate bridges. Unlike an aluminium plant that recycles only cans, Cozipa recycles any scrap steel. Appliances, cars, ships, trains, even the guts of old buildings.
This is where we start the process of refining the steel.
As with aluminium, it begins with fire. They load scrap metal into a gigantic cauldron, then add an impure form of iron called pig iron. Here, the ratio for making steel is 20% scrap and 80% liquid pig iron, heated to 1,350 degrees Celsius. The cauldron holds 140 tons of metal, the weight of 2 Boeing 757s. A chemical reaction refines the scrap and iron into steel. Until half a century ago, refining took place in open hearth furnaces, a time-consuming method that took up to 9 hours. Today, it takes less than 45 minutes, thanks to a wonder of modern engineering, the basic oxygen furnace. The oxygen furnace dates to the 1950s, but now this São Paulo plant is refining the refinery and taking steel production into the 21st century. Cozipa is only the world's second steel mill to license a process called cojet technology, a truly supersonic innovation. The technology turns this man-made volcano into a supernova. It begins with a stage called charging, loading the furnace with scrap metal to control the extraordinary temperatures of the process. Then, up to 300 tons of molten iron. Next, a hollow lance with a patented tip blasts a laser-like jet of 99% pure oxygen into the steel bath at Mach 2, twice the speed of sound. The temperature soars to 1,350 degrees Celsius, 1/5 the surface temperature of the sun. The yield, liquid steel of exceptional purity, but still flawed. Impurities that could weaken the steel remain. Engineers add limestone to absorb them. The impurities float to the surface in a layer called slag. In the last stage of refining, the liquid steel is tapped and the slag is separated. Even the waste is not wasted.
A escória contida no conversor, ela pode ser destinada para vários fins.
The slag inside the converter can be used for many things, mainly road paving and also fertilizers. So this liquid slag will be cooled and transformed.
Making steel can be lethal. The hazards? Constant movement, mammoth weights, and hellish temperatures. The molten metal is so hot, it will instantly vaporize flesh. In the final stage, the refined steel becomes a long slab, cut at roughly 5-meter intervals for transport.
This product can vary from $500 to $600 a ton. Each plate weighs about 10 tons, so we can evaluate this load at around $300,000.
With prices like that, a steel mill like Coziba is a gold mine. A high-tech alchemist's lab that transforms pig iron into treasure. Yet São Paulo's greatest feat of alchemy doesn't happen with scrap metal or even soda cans. It happens with an ordinary carton you find in your refrigerator. It's called Tetra Pak. This wonder material holds your morning juice, your lunchtime soup, your bedtime milk. It looks like simple cardboard. It's actually an ingenious blend of 6 layers of paper, plastic, and aluminium, fused tightly together. Paper stiffens the package. Plastic keeps it watertight. Aluminium blocks light and oxygen to prevent spoiling. Just one problem. Tetra Pak is so well made, no one could separate its components for recycling. This wonder material has always wound up in the dump. Until now. And the problem was solved right here in São Paulo. To grasp how a Tetra Pak carton is reborn, you first have to see how it's made. This is a Tetra Pak factory outside São Paulo. The first step is the one you'd think would come last, printing. To protect the environment, they use water-based paint. A precisely timed strobe light controls the quality of the printing. Though the paper appears motionless, it's actually moving at 180 meters per minute. The flickering light freezes motion to the naked eye. Fernando von Zuben is the environmental director of Tetra Pak Brazil.
What he's doing here is checking to see if the product quality is good or not. If it's not, the computer will send a message so that the paint will be corrected for the printing.
Next, laminating the paper with alternating layers of polyethylene, a plastic, and paper-thin aluminium. Finally, they cut the spool for shipment to packaging factories to become milk cartons, juice cartons, and soup cartons. Those cartons end up here. Now the cycle of rebirth begins. It starts